them are just called rectus muscles, and then they're named based on their location. So this one is superior, so we're going to call it superior rectus. This one over here is on the medial aspect, right? This is the nose, on the medial aspect of the eye, so it's going to be called medial rectus. This is on the lateral aspect, so it's going to be called lateral rectus. There's one we could take, if we took this one off, it'd be easier. There's one down in here that's on the bottom part of the eye, and that's called inferior rectus.
So there's 4?
Those are 4.
Inferior.
So it means 4.
Yep. So superior, that could be lateral, medial, inferior. And then there's one that comes up through here, and it has this little teeny tendon that goes through a notch in the bone. And that bone is called the trochlea, or that notch is called the trochlea.
The little
And
one.
because it goes through and comes back down, it's going to pull the eye down and out. And that's called the superior oblique. There's another one on the bottom. Down here, you can see it comes in at an angle, and that one's called inferior oblique. The trochlea is controlled by which cranial nerve, do you think? Sorry, this superior oblique is which nerve? I just gave it away. I said it accidentally.
Oblique.
Trochlear nerve.
Okay, so it's right here.
And then the lateral rectus is controlled by the abducens nerve. So it abducts the eye, pulls the eye away. So if you knew that's trochlear, that's abducens, all the other 4, or the remaining 4 muscles, are all controlled by oculomotor, cranial nerve 3. All right, while we're still on the outside, let's pretend this is back in place. Right. These little glands at the top are called the lacrimal glands. When we cry, tears come down, they wash across the cornea of the eye, and then they go down into this little lacrimal duct. The lacrimal duct empties out as the nasolacrimal sinus duct into the nasal cavity. That's why when you cry, your nose runs. All those little tears are going down through the ducts and into your nose. We'll use that model, I think. This model has the cornea in place. The white of the eye is the sclera. Pop that off without breaking it. So the sclera is the white part. Behind the cornea is fluid, and that fluid is the aqueous fluid. That's the real watery fluid. And then we have the dark region of the retina called the choroid. The choroid is continuous with the pupil. That's the colored part of your eye. That's what gives your eye color. If you pop that off, there's still some aqueous humor in here, but then in the back, holding the retina in place, as well as the lens, is the vitreous humor. That's the thick humor. On this little model, you can see the retina. Right? Choroid was the dark, the retina's in the back. That's where all the rods and cones are. And the the choroid is continuous, and it forms these serrated portions called ciliary processes. The ciliary processes have little ligaments that extend out, and they attach to the lens. And they're called suspensory ligaments, and they can be stretched or pulled. And when they do, they cause the lens to either flatten or bulge up. So we can change the shape of the lens to put the light on the right area of the retina. This is called the optic disc. This is where the optic nerve extends back towards the brain.
Does it yellow mean something that
This whole area is the optic disc.
Okay.
Yeah.
I was actually the yellow was.
And on one of these, oh, there it is. On this little portion of the model, there's an area on the retina called the macula densa. And at the very center of the macula densa is a area called the fovea centralis. And the fovea centralis has the highest number of cones. So that's for real high acuity vision and color vision. And from there, they start to dissipate. They get smaller and smaller in number, and they get overrun by rods. Rods give us our depth perception of night vision. That's it.